Good morning, good afternoon, good evening, everyone, depending on where you're located. Welcome to the second edition of our ZTNA Table Talks. I'm Ixta Gerard, and I'm delighted to have you all join us today in our monthly webinar series, where we delve into the world of Zero Trust Network access. Today's session with a federal focus is titled, How Zero Trust Access Secures Disconnected and Tactical Edge Operations. We will explore this topic in depth, providing valuable insights from our ZTNA experts presenting today, Jonathan Roy, Sales Engineer for Appgate Federal, and Aaron Palermo, Senior Solutions Architect here at Appgate. Before we kick off, a couple of things to note. This webinar is being recorded, and you will receive the recording within 24 hours. If you have any questions, you may submit them in the Q&A panel, and we will try to answer them during this live session. If for some reason we don't get to answer your question, someone will follow up via email. Without further delay, I'll pass it over to Jonathan and Aaron.
Hi, good afternoon. I'm Jonathan Roy, a sales engineer with Appgate Federal. Looking forward to having a discussion with you guys today about our ability to do the tactical edge, disconnected operations, also air-gapped environments. I'll hand it over to Aaron for a quick introduction as well.
Hey, my name is Aaron Palermo, Senior Solutions Architect here at Appgate, and I'll be doing the live demo portion, and definitely welcome any questions that might arise during the presentation.
Yeah, great. So we're going to only do a few slides here. We want to jump into the live environment as quickly as possible, keep it engaging. Being that this is a live session, we're hoping to get questions from the audience. So feel free to post those and we'll answer those along the way and toward the end as well. So to kind of do a quick level set on Appgate, I'll use the first slide or two here to kind of explain the base capability, and then we'll walk into kind of the tactical edge piece, and also from a kind of just explaining the overarching approach, but also seeing the live demonstration. So starting off, Appgate software-defined perimeter. From a zero trust architecture perspective, we are the zero trust network access component of that overarching architecture. Our goal is really to make sure the right user gets the appropriate amount of access to the right resource at the right time. We do that by combining a number of different elements. It starts off with understanding as much about the user as possible. So think, roles, groups, and attributes about that user, understanding the compliance or the device health. So think identity plus device. We want to learn as much as possible, whether it's, a bring your own device or a government issued or government furnished piece of equipment. Is there a machine certificate? What processes are running, et cetera. But we want to take those two elements in combination with other environmentals like geographic location, risk score, a number of other elements as well that could be external to our platform. Let's say there's security events in a SIM environment, but just think of us taking all those pieces of telemetry in aggregate to decide what a user should or should not be able to access, and then continually monitor that user session. So if there's any changes in what we've learned, we can make real-time changes to their access policy. On the right-hand side here, you'll see the number 3. This is just a very high-level graphical depiction of how Appgate is normally deployed in an enterprise. But again, we're going to pivot here very quickly to the tactical edge piece. But from just a base capability perspective, you'll see circles with slashes through them. Those represent our gateways. If you're familiar with the NIST 800-207 framework, those are our policy enforcement points. So think of it as you as a user. When we learn about you, your device, and those environmentals, we make connections to these Appgate gateways, which are the points of presence. There's two key pieces that we like to focus on with how Appgate operates. You'll first take note that it's unlike a normal VPN where you have one connection to one part in your enterprise. If you look at the graphic, it's a one-to-many connection. So the idea is you're directly connected to the resources or sites or locations that you need to have access to. And it really avoids a lot of that hairpinning. By hairpinning, I mean sending all of your traffic to a single location and then relying on back-end routing over your WAN or other type of network infrastructure to get you to the appropriate location. One of the key pieces here that we're going to start alluding to a little bit is, the overarching kind of value proposition when you have this style of architecture. So the first one I already talked to, which is directly connecting you to the resources. But you want to think of it from an adversary's perspective as well. Before you may have one primary ingress point into your environment, but with an AppGate style approach, as you can see, there's like 4 different ingress points. So how do we protect that? So we have a technology that we use to keep that enterprise edge cloaked. It's called single packet authorization. And actually, I'll let Aaron kind of talk a little bit about how we use that single packet authorization to really protect that overarching enterprise edge and how we use that for the tactical edge environment as well. Aaron, do you have a few words about that?
Right. So single packet authorization is a patented technology that we use to use encrypted UDP packets that are sent to the controllers and gateways that are passively then decrypted on the controllers and gateways to pre-authorize the device to even start a TCP communication session. So those packets are encrypted on the client side, and this is done by the AppGate client. They're timestamped encrypted, sent to the AppGate appliances, passively decrypted, and if they decrypt properly and are validated, only at that point can the user's device initiate a TCP session to the AppGate controllers or gateways. This is a way that we use to prevent detection on the network. So the AppGate appliances, the controllers and gateways don't respond to ICMP. They don't respond to any TCP port probes. You can nmap these all day long, and you're not going to be able to find them on your environment. So single packet authorization is what enables that cloaking.
And we find that very useful, especially in the DoD space where you're operating in, contested environments. You may have 4 deployed assets and they're either reaching back to, headquarters resources or just kind of operating in their kind of local area. But the idea is you don't want to give the adversary a glimpse into kind of where your protected resources are. So that cloaking piece is a critical part of again operating in those contested environments. This is where we start getting into how we're able to actually support the air-gapped and disconnected operations piece. So this is kind of that transition story. So you may have heard some literature or seen some marketing around AppGate is a direct routed solution, and really, what does that mean? So on the bottom section, you'll see a cloud routed solution, and that's really when ZTNA vendors, the way they approach applying or providing their capability is they host a lot of that infrastructure in their cloud. So if you look at the bottom there, you as a user, you don't directly connect to, let's say, your data centers, or maybe in AWS, you have some VPCs, or in Azure, you have some VNets. You don't directly connect to those environments. You have to send your traffic to a cloud first. So for example, if AppGate required this, we'd have an AppGate cloud and you send all of your user traffic to the AppGate cloud. Then we do a brokering or a proxy to your resources. Now, if you think about kind of that fundamental piece of that architecture, if there's a cloud dependency, right, where if I have to send my traffic external to my network, go to a cloud hosted resource, it's going to be very difficult for you to do disconnected operations, right? Where if things have to go to a cloud SaaS service or a cloud hosted service before they can let you connect, it makes it very challenging for other solutions to meet that, disconnected use case or meet the ability to do zero trust in a air-gapped environment. So at the top here, we're kind of depicting AppGate's direct routed approach. So we have the same components under the covers. We have a controller, which is where we write our policies and decide given this type of user with this type of device, this is the type of resources they should have access to. We both have the same type of policy enforcement point that lives, on the data center side or cloud side, kind of depicted here with the gateway or the connector. But the idea with AppGate is those components don't live in an AppGate cloud service. They can live within your existing boundary, whether that's in your data centers, in your VPCs, in your flyaway kits. There's no need to externally route any of that traffic outside of your existing security boundary. So you get all the benefits of zero trust network access without any external dependencies. So this is really one of the fundamental reasons that we're going to be able to show you disconnected operations here during the live demonstration. So this is kind of where I want to transition directly into the demo environments here. I'm going to walk you through a common use case that we see within the DoD for forward deployed operations. So starting on the left-hand side, you kind of think of that as your ground station, your tactical operations center, where they're projecting capability in those forward deployed environments. And that could be through a number of different media. Typically, it's, a SATCOM related infrastructure, but in some scenarios, it may be 5G, et cetera. But the idea is you have a kind of a forward deployed element that's acting as that ground station, that kind of central node connecting back to the larger DoD networks. You're projecting your capability into the battle space, right? So you may have in the center there, you may have, mobile stations, airborne assets that are able to, project connectivity out to the warfighter on the very far left, where they're using technologies like radio over IP. They may have private 5G, things like Starlink. They may have Wi-Fi meshes between the different elements that are forward deployed. But the whole idea here is, well, how do you do zero trust in an environment where at any point in this infrastructure, there may be an outage? It may be due to low bandwidth. It may be because comms are down. It may be due to the adversary intentionally, taking out part of your communications infrastructure. So how do you persist the right user to the right data at the right time when you don't have that external connectivity? So that's really the premise for what we're going to be talking to and showing you in the live demonstration. To kind of summarize those pain points into kind of something that you can digest here, we were really trying to solve for the current limitations for throughput. We were trying to solve for the inability to use multi-modes of communication. So if there were different modes, for example, SATCOM and 5G and MPLS and really any other network, can I use those all at the same time? And then get rid of the kind of legacy way that tactical comms are deployed today, which is, in flyaway kits that may have physical routers, physical switches, physical HAPI devices. And can I do all of these things in a kind of a software defined approach, right? So we're all into software defined enterprise, but can I take that software defined approach and deliver it to the tactical edge? From what you'll see throughout the demo is really trying to address these three use cases. The first is if you're a forward deployed user, so I'm, in the field and I'm trying to access reaching back to headquarters or CONUS resources and doing that in a secure way. So that's very straightforward. That's kind of the table stakes for a tactical use case, but it then gets more interesting as the use cases progress. The next one is if I'm stationed at headquarters and I want to get access to more real-time telemetry. So maybe I'm doing analytics and the data set that I have is currently in the cloud. I need to be able to reach out into that forward deployed edge node and get maybe more real-time data. So think of it as being bidirectional, not just being able to have, those forward deployed users reach back, but have garrison resources reach out. And the last one is the critical piece where you have the forward deployed user needs to be able to operate while those backhaul connections are disconnected. So again, you've lost access to the internet, you've lost access to the normal WAN infrastructure, and how do you do that? So this is a very simplistic view on how we've achieved that with AppGate. During the live demo here, which is on the next slide, you're actually going to see the schematic overlay of how we make this function, but this is just a simplified view for the tactical edge piece. So it starts with a very kind of a typical enterprise where they have, cloud resources. So we're showing some applications that live in the cloud. We're showing some applications that live in a data center here on the right. You'll notice that we have the AppGate components living in front of these resources. So again, these are the pieces that are deciding who has access to what. On the left-hand side, this is a snapshot of what one of our flyaway kits looks like. It's really agnostic to the form factor. So whether it's a Snowball device or an Azure Edge device, or even a kind of an x86 based hyper-converged platform, we wanted to show that, yes, there's applications that can be hosted local to that user, but you also want to take note that there's actually AppGate capability also co-hosted on that infrastructure. So the use case was pretty straightforward. You as a tactical user here on the bottom need to be able to connect to your tactical edge suite and still have access to the resources that are available to you locally. And if the network is available, you can reach up into, let's say, the cloud resources or headquarters resources. But again, the focus is on how do I make sure the right user gets the right access at the right time if this network in the middle here isn't available. So that's, again, kind of the strength of AppGate. In order for us to achieve this capability here, we do not require that the user has to reach the internet, send their traffic to an AppGate cloud, have it be proxied or brokered, and then come back down to the tactical edge. Literally, the user can have a zero trust experience anywhere. So again, they can just locally connect to that AppGate environment and then have the appropriate amount of access to the resources, which is really powerful if you think about joint operations or coalition environments where you still want to have, the appropriate least privileged access controls applied when you're operating, again, with partners for the mission. So Aaron, did I leave anything out here, or did you want to jump into the live demonstration portion?
I think that's a pretty good overview, and I can take over the screen share and jump into the live presentation. I'll just need you to stop sharing. Perfect. Okay, so I'm hoping you can see my screen. This is just a graphical representation of what we're going to be going over. So on the right side, we have an edge network. You can think of this as, a 1U server in the back of a Humvee. And on this server that I have on my desk, I have a firewall on the outside, and I have an AppGate gateway inside that edge network. And the protected resources in that edge network, we're going to look at container workloads, video streams. I have virtual host management to manage the actual underlying hypervisor, and then also domain controller and Windows client. And the edge client, which will be a VM on my machine, is going to be connected over the red path. So the red lines, that's the edge user. And then on the left side, we'll see those enterprise resources, the protected resources. We have a container workload that we'll be looking at, some video footage, and those enterprise resources live in AWS. And then my laptop host will be the internet connected client using the green lines to reach into the edge and also to reach those enterprise resources. So again, we'll be looking at edge resources, edge network, and edge client, and then those enterprise resources and the internet connected client on the left. And I'll be referring to this diagram again in a little bit. So the edge demo VM that I have on my screen here, we have an AppGate client running there, and then also my laptop, we have an AppGate client running here. And what we'll see is I'm doing a continuous ping, really just to show latency here to a containerized resource. So on the left, on my host machine, that is reaching to the enterprise resource in AWS. I have roughly 65 to 68 millisecond reach to AWS on the West Coast. So pretty reasonable latency. We can see that the edge resource, that ping time is significantly worse. We're looking at about 400 milliseconds. So we see that, the edge device is connected to edge Wi-Fi, and I'm currently in a hotel room, so I'm connected to the local Wi-Fi on my host device.
And that edge Wi-Fi represents, that forward deployed element where they have that local Wi-Fi mesh, just to give some clarity there. And again, on the enterprise side, he's showing the connectivity from the internet to the enterprise resource. Go ahead, Aaron.
Right. So first example is if I want to reach back into headquarters to get some high-res video, that's going to sit there and buffer. Right now, I've got a 2 megabit connection and I've got almost a full half second of latency. So pulling that high-res footage from headquarters is really just going to sit there and buffer for quite a while. Whereas low-res, it's going to be a little bit more performant. I might actually get a few frames to come through here. But again, we're going to show that as that buffer is barely leading my play line there. So while it works, I can play low res, I can't play high res, I can reach back to headquarters. And then likewise on my host machine, if I go to the edge video, and I had some caching issues, that's why I'm loading this in incognito window. So if I'm looking at the high res footage, again, it's really just going to sit there and buffer. So the high res and low res are the same video. The low res is a significantly lower resolution, lower throughput.
And if you want to extrapolate that, I think you had a good example, Aaron, about kind of back to that use case I talked about. If I'm a Garrison analyst trying to get more real-time data, this doesn't have to be video per se, but it could be, maybe I've captured a lot of telemetry or devices in the field and I want to do some analytics on them, and having to, if you think about having to reach out over that WAN connection, and it's going to be a pretty low performant experience, right? Where you can't do much file transfer. So the idea with the tactical edge side is when you have that compute local to those users, if you can grant that analyst, direct access to the tactical edge node, they're going to be able to process those things locally and only bring back relevant data. So that's a pretty important part to kind of what Aaron's showing here. Yes, we're using videos to kind of show, what can be streamed and what can't be streamed, but just think about just overall data in general, if that makes sense.
Right. And a practical example there is if you're out in the field and you have an edge network, say you have, adversary, you've seized 10 or 20 laptops, forensically imaged those drives. To pass those terabytes of data over this edge network could take, days or weeks. The other alternative is put those on a plane and try and get those back to headquarters for analysis. And what we want to enable here, even over a 2 meg connection with high latency, if we can get that, an analyst, say internet connected client, analyst tool set deployed in a container workload or even on a management VM, they would have access to locally tear apart those forensic images, gather those files of interest, and then instead of terabytes being piped over that high latency connection, really we can look at what is critical to get back to headquarters within the next, minutes or seconds. And that could significantly reduce the traffic from, terabytes from those laptop images, full images, to just the kilobytes or megabytes that we need from the documents or contacts or other information that we get from those confiscated laptops, and bringing the really critically time sensitive and high intelligence resources, bringing that information back to headquarters for dissemination. And then, we see the container workload here, and then we have the 10.10.1.212 IP address. And that's what I'm continuously pinging here. So right now it lives in AWS, and from my host workstation, not bad. From the tactical edge, that's pretty terrible. And since there is a containerized or a Kubernetes environment in both infrastructures, I can actually migrate that workload. So again, that Docker image has already been pre-staged. I don't have to download that. That's work done ahead of time. But if I want to migrate that workload and actually see what that looks like, what we're going to see is the latency on my host workstation. Now I'm reaching into the tactical edge. So now I'm looking at, 300 to 400 milliseconds of latency, whereas in the tactical edge, I'm now looking at single digit milliseconds of latency. So that really just highlights if I have control over an application, and this is just a single source of truth application. If I need one application that is a source of truth living in one place or another, I can pretty easily migrate that workload. Another option would be if I had the same application that could live in both places and didn't need to be a single source of truth. I can deploy that very easily on the tactical edge. So I can have my local workstation keep pointing to AWS, and I can have the same application, but potentially with a different data set on the tactical edge. It's very easy to deploy and switch back and forth. So if I switch that back from the edge to AWS, again, this is Appgate controlling the routing, and with no downtime, I see that the application is now going to be, pretty poor performing on the edge, but back to the original performance for the internet connected workstation. And then this entire setup, again, on my desk is a standard workstation, a standard desktop with the battery, with the wireless access point. The whole thing is under 15 pounds. It can run for about 10 hours on the battery. Very, very easy to deploy, very easy to carry in a backpack. And then the other thing that we're really going to focus on is what happens in a disconnected environment. So here I'm connecting to AWS, and I start to see that ping timeout. And within a few seconds, what I'm going to see is actually a mirror, or not a mirror image, but an inverted image of what do I see on the tactical edge, and how does that look on the internet connected device. So I see that I've lost access to the tactical edge, and on the tactical edge, I still see those headquarters links. They just went gray. And then this is what a edge user would see. I still have access to, my edge video. If I want that high res video footage, that's still going to play really well. It's still going to be really low latency. I still have access to all my local resources, but that SATCOM link is down. I have no outbound connectivity. I only have secure access to my local resources. And then once that SATCOM link comes back up, either did some troubleshooting, or we got a different connectivity. Maybe we switched over from SATCOM to 5G because now we're in range of a 5G tower. Then I see the headquarters come back, and also from internet connection, I can now get access to my edge resources again. So that's an example of what does it look like when that link fails, when I am in an isolated environment, and what does it look like when that access is restored. So we've gone over link failure, workload migration. How do I enable the headquarters-based analyst to reach into the tactical edge, potentially do some forensic work on laptop images, bring back those really high-value pieces of information, that small finite set of files that I might want to disseminate very quickly without waiting for those entire laptop images to come back. And then also what that latency looks like. So I think that covers the demonstration portion of it.
Yeah, that was great. And I have a couple of questions. So what I'll do is I'll answer these questions, because some of these actually I have in my presentation. So the first one was the difference between Appgate and other ZTNA solutions. So I have a differentiators piece that I'll walk through. Aaron, if you could tee up a response for maximum number of concurrent sessions and gateways and controllers, and then I'll answer the question around the policy enforcement and the policy information points. I'll bring something up for that. So, but for the first question here, kind of what makes Appgate different. So I kind of wrote these out. So it really starts off with, if you think about, zero trust network access or just zero trust access in general, there really isn't a lot of frameworks that defined from a compliance perspective or a risk management framework perspective, what capabilities organizations should be looking for. So for example, we're dealing with AppGate, we're deploying in unclass, secret, and TS environments very frequently. So trying to achieve things like a NIAP protection profile and common criteria, et cetera, are still challenging, right? Because there really isn't a quote protection profile for zero trust network access solutions. NIAP is publishing an updated version of their software defined networking protection profile, but that really doesn't fit into the ZTNA piece. So what we wanted to kind of differentiate is AppGate has already achieved some of these certifications here, the NIAP common criteria, alignment with FIPS 140-2, and we're moving to FIPS 140-3. We're in flight for our new protection profile, so that we can, with confidence, have the credibility to say that not only can we do this for IL2 through IL4, but IL5 and above. So we have a number of implementations in IL6 and TS environments, but those are, again, in air-gapped environments. But from a general perspective, some of the things you should be looking for, that what makes AppGate different is the certifications behind the product beyond just things like FIPS 140-2, which isn't good enough for even things like IL5 CUI. The second piece is we've gone through a number of penetration tests, and some of the things that we're able to thwart not only adversaries, but pen testers on is things like man-in-the-middle attacks and session hijacking. So AppGate actually uses mutual TLS 1.3 to secure communications. I'd say a lot of the competitors out there are using TLS either 1.2 or even just TLS 1.3, but they're not using that mutual piece. The mutual piece means both the client and server side are mutually authenticated, making things like man-in-the-middle attack extremely difficult and session hijacking extremely difficult. So that's one of the other pieces when you're looking for how can I ensure that my data hasn't been manipulated in flight on way to its resources. Again, the cloak piece is pretty different about AppGate. That technology we're using called single packet authorization, allowing you to operate in contested environments. Another one would be, the continuous monitoring and evaluation. There's some literature for competing solutions about how they'll check, let's say compliance state when users sign in, or they'll check it hourly or maybe every 12 hours. We can actually continually assess and evaluate a user, whether it's things about their identity. Let's say a group got changed from red group to blue group, or their device health changed, but you want to have that go from hours or days down to something much more real time. So that's another benefit of AppGate. We do have a pretty robust network port and protocol support, and a lot of that has to do is that we don't require the user to send their traffic to our cloud and broker it or proxy it. So we don't have any challenges with port forwarding or supporting things like VoIP or ICMP. We see some comments, some other solutions out there that can't manage simple use cases like I need to connect to my infrastructure and I want to just do a ping or a trace route to make sure the path between me and my application is good to go. Believe it or not, some of these solutions can't allow you to do ICMP or an NS lookup or a trace route or support VoIP communication. And the last one that's really kind of different, again, I'd say 99% of the competitors in this space rely on a send your traffic to me model, back to that, come to an AppGate cloud or come to a vendor A, B, or C cloud so I can do all this capability. AppGate doesn't have that dependency. So those are probably the 5 or 6 things I would say making AppGate different when operating in these environments. Aaron, did you want to talk to the controller and gateway while I bring up a diagram for the policy information point?
Yes, question is, what's the maximum number of concurrent connections with the controller and gateway? So the controller is really the authentication portion. There's not a persistent connection to the controller. And you think of that really as how many users can I authenticate per second? And that's based on the amount of CPU and memory. And then on the gateway side, that is where the persistent tunnel is connected. And gateway, we scale that out horizontally. So it's not just one gateway in front of your protected resources. It could be 2 to 20 gateways in front of your protected resources. And typically that is 1,000 users per CPU or per 2 CPU. So I would probably cap that roughly 8,000 concurrent users or concurrent tunnels per gateway. And I've also posted a link to the sizing guide. So on the AppGate admin UI, sorry, on the AppGate admin guide, we have a sizing chart of, you would expect this many CPUs, this many gigs of RAM for a gateway sized to support this many users and this much throughput. And then I can also speak to the, okay, you have a graphic there, but for the policy information point, we integrate typically via API with a number of backend systems. So one example is if we want to check the compliance, the status of a protected resource, we don't need to run an AppGate client on that backend protected resource. If we want to ensure that that is patched and has antivirus or whatever endpoint detection up to date, we don't need to reach out and touch that protected resource. We shouldn't reach out and touch that protected resource. We'd like to ideally integrate with the API that aggregates that source of truth information to ensure that the protected resources users are getting to is still in compliance, it's still secure. And then we can allow or deny access to those protected resources based on those API calls and the information that we learn from those authoritative systems that have that information.
It's very common. So I brought up a diagram. I apologize, I had to zoom in to make it legible. But from a policy decision, policy enforcement, policy information, kind of the whole policy authoring, all of those components, again, it's primarily API driven. So it's very common for us to go get additional telemetry or information from a number of sources. So in the DoD, it's very common for me to go talk to the SIM platforms, ACAS, HBSS, ITSM solutions. So part of my logic for making a decision doesn't just have to be things that AppGate's learning. It could be, for example, if I want to grant administrators access to a resource, maybe I want to go check if Remedy or ServiceNow has given that user a ticket, so I can actually use that as criteria for granting access. Or maybe there's been a general compliance scan done by Tenable across my entire environment, or Tanium has done a compliance scan across my environment on not only the user side, but on the workload or server side. So again, part of the criteria that we can leverage from those platforms would be, I'm Jonathan Roy, I'm part of the Red group in Active Directory. I should have access to the Red application. And just because my device is stick compliant, we may want to make sure that the Red app itself doesn't have any CVEs, and we're getting that telemetry from Tanium or Nessus. And so the idea is kind of use all of these existing tool sets that enterprises have as part of the decision-making process in AppGate. All right, hopefully that answers the question there. And let's see if there's any more questions here.
There was a question about what is a collective, and the AppGate collective just refers to the entire AppGate system that's comprised of controllers and gateways working together to provide authentication and secure access. So you can think of a collective as all of the gateways and controllers that are working together.
So another question here is, does AppGate work inside AWS networks like inside VPCs? So this goes back to, again, this is a very simple graphic, so I apologize, and we'd be more than happy to, have follow-on conversations with some members of the team to kind of give a more deep dive. But in short, think of these circles, the AppGate gateways. They live inside of your environments, and there's typically one to many of these gateways, these virtual gateways that sit in front of your resources. You kind of have two choices in clouds. You can create like a zero trust access zone where you're hosting a lot of the AppGate gateways that then create connections to your VPCs or to your VNets. or you can choose to put the AppGate gateways directly in your VPCs. If you, let's say you had multiple, so AppGate is a little bit more close to the data. But yes, I think what you're asking is, can AppGate, enforce access controls into your VPC environments? The answer is yes. See what other questions we have here.
We have one: who's in charge of providing the 10 IP to the client, the gateway or the controller? And that's the controller, definitely. So again, in our multi-tunnel example, again, AppGate has patents on that multi-tunnel connectivity. The controller assigns that tunnel IP, and that tunnel IP is used to connect to all the gateways that the user is allowed to access protected resources through. So the short answer is the controller provides that tunnel IP to the AppGate client.
All right, there's a question around, I think, taking this architectural model to highly regulated sectors like the financial services industry. This is a long question. Hold on, I can read through some of this. So yeah, we've definitely, so AppGate in general, of course, can be applied to those models. Now, if you're talking about disconnected operations, we're kind of having more of a tactical lens into this environment. We've thought about use cases. We have a whole commercial team that's kind of taking what we've done on the federal side and applying it to some of their use cases. So whether it's, the oil industry where there's, remote oil platforms, and they obviously have compute infrastructure for the employees that are kind of working in those offshore environments. How can they, continue to do their job and, still leveraging things like zero trust to grant access to resources? That same model could be applied to, something as simple as like merchant marines or even cruise liners that are pretty much floating data centers, but in essence, they still need reach back. But from a kind of financial services model, I think a lot of the accreditations that we've achieved, whether it's, the FIPS 140 stuff or some of the NIAP pieces or common criteria, should have applicability, because a lot of that all maps back to 853. And on those financial services side, as an example, whether it's PCI DSS, or if you're looking at HIPAA compliance, or if you're looking at really, whether it's Sarbanes-Oxley, they all kind of map back to those kind of NIST level risk management frameworks where there's a one-to-one mapping for AppGate into those environments. So it's very easy for us to do a crosswalk if that doesn't exist for your specific silo that you're thinking. But I do know that we have mappings for things like PCI DSS, Sarbanes-Oxley, and things like HIPAA. So if that's an interest, we can definitely send that along. And I got to read the other half of this question. Aaron, could you take another one while I kind of finish reading this one?
I think we've touched on the differences between AppGate SDP and other ZTNA solutions. So I can't necessarily speak to other solutions. I'm not an expert on Palo Alto, Citrix, Pulse Secure, but the differentiators that Jonathan went over. One, keeping that edge cloaked, making it completely undiscoverable, so that if there is a Shodan of the world, we're not going to show up on those scans because we don't expose public TCP ports. We're not going to have the certificate fingerprinted from an AppGate gateway or controller because that's undiscoverable without single packet authorization. So it's going to be much, much harder for, if a CB is put out and somebody wants to go and search for your endpoint of choice, it's not going to be possible to go to a data aggregator and search that. So that's the single packet authorization portion. The other part is we provide a direct path to the gateway that sits in front of the protected resources. So the multi-tunnel is also a large differentiator. And then again, I can't speak authoritatively to the other solutions, but the ability that AppGate has to reach out to other APIs, discover information, and also accept inbound API requests and information in put or post form makes it so that we can integrate very tightly with a lot of systems, and it's easy to do if you have a development background. It also makes it easy to deploy this as code, manage it as code, keep the infrastructure version controlled if you want to do that. So those are I think some of the highlights there.
There was a long question. It was kind of going into like kind of our success stories, and kind of how we differentiate, what wins have we had when having to compete with other SASE products. So I'll kind of just use some of these. So for example, AppGate is currently used. Probably one of our bigger implementations is with the US Air Force. So if you've ever heard of the Platform One, which is the Air Force's software factory, they're using AppGate to do what they call cloud native access point. They were looking for a way to grant developers and users access to cloud resources without having to do the traditional hairpin, which was using what was DISA's JRSS VPN, coming into DISA and their internet access point, routing through the DODN network, and then having to route out of a cloud access point. So it was like 4 or 5 kind of larger hops, but under the covers, it was about 15 hops of a user having to traverse DoD infrastructure just to get to cloud resources. So they wanted a way to have users have that direct access. So that's why organizations like Air Force and Platform One are using AppGate. That capability again is called Cloud Native Access Point, and that's actually being moved over to Cloud One and being offered as an enterprise service. So you can consume Cloud Native Access Point as a service from the Air Force. Some other interesting implementations that we have were with Space Force as an example, where they were looking to provide zero trust access to not just cloud things, but they were more focused on on-premise things as well. So I know we've been talking primarily about remote users coming in, but this solution was designed for more of that universal ZTNA where it's on-premise users, it's remote users. So having a single solution that can solve for both, especially if that on-premise environment has a potential to lose internet connectivity, but yet you still want to provide zero trust access, was one of the main use cases there. I'll pause here, see if there's any more questions. And Aaron, do you see anything else? Otherwise, we can turn it back to Itza.
There's one about creating looks like a second appliance to run the portal. The portal does need to be a separate appliance from the controllers and gateways. The portal actually is our client list solution, and that runs the AppGate client in a isolated Linux namespace on behalf of each user that logs in. So that would need to be a separate appliance, and sizing for the portal is in the sizing guide on the AppGate admin guide. AppGate admin guide is sdphelp.appgate.com, and you can find the portal sizing for the number of users you want to support on there.
Okay. I think we kind of ran through most of the questions, Itza. I'll hand it back over to you to close out, I believe, unless we want to wait a few minutes for any last minute questions.
Sure. We'll see if anything else comes in. I think we're ready to wrap it up. Well, thank you, Jonathan and Aaron, for the session, and to our audience, thank you for being a part of our CTNA Table Talk today. As a friendly reminder, the recording of today's session will be shared with you tomorrow. We highly value your feedback, so please take a moment to complete a short survey at the end of this webinar. And thank you again for joining us today. Have a great day. Thank you.
Thank you.